Hi, welcome to our channel True Up. The largest pure foundry business in China, SMIC International Corporation, was subjected to limitations by the US government for 7 months before the Chinese semiconductor sector started to establish itself in the new global market environment. Major Chinese chip manufacturers, including SMIC, continue to develop 14 nanometers and 12 nanometers process nodes based on FinFET technology, using mature deep ultraviolet lithography toolsets and processes, which make up the majority of semiconductor production today, despite being effectively excluded from the most recent semiconductor manufacturing tools required to catch up with global leaders like TSMC. SMIC sees a chance to concentrate on these established silicon manufacturing techniques, which may boost output and thus have a bigger effect on its bottom line. In fact, SMIC's co-CEO Zhao Haijun once stated that the firm has chosen to expand its spending by $1.1 billion to $4.3 billion in order to fulfill the demand for chips in communication and automotive applications as a result of the favorable response from customers on its 14 nanometers process capacity. We anticipate that China will be entirely self-sufficient in 14 nanometers technology by 2022. The South China Morning Post said that registrations of new domestic semiconductor businesses had increased by threefold since early 2021, possibly generating a sizable domestic market for chip-making services like SMIC. The government of China, which is pushing for China to become self-sufficient in silicon manufacture that year, is the main force behind the country's semiconductor sector. Although U.S. restrictions limiting U.S. technology exports to Chinese enterprises have significantly hampered this aim, we nevertheless believe that Chinese industries are still capable of manufacturing chipsets based on more advanced process nodes. Although complicated silicon required for high-performance computing and artificial intelligence is produced using cutting-edge technologies, there is still a considerable demand on the worldwide market for chips made using established silicon processes. For instance, the absence of mature silicon processing capacity is the major source of the scarcity of semiconductors impeding the automotive sector, since many aging fabs retired early at the start of the pandemic. We estimate that mature process chips account for nearly half of worldwide semiconductor spending. Therefore, with or without government assistance, China's capacity to develop a vibrant and thriving semiconductor sector is still very much a possibility. China Mobile has entered the market by founding Xiansheng Tech, a semiconductor manufacturing company that would specialize in chipsets for Internet of Things, IoT, devices. It intends to modify and improve its present IoT business unit, which has more than 850 million connections as of right now, using its own IoT chip design. The future of Chinese semiconductor production is greatly enhanced by the desire of the largest wireless operator in the world to bring silicon design in-house. Additionally, China's Vice Premier Liu He has launched a program aimed at utilizing the nation's expertise and resources for semiconductor production in order to position China as a possible global leader in compound semiconductors. These are chips made from a combination of non-silicon materials, such as silicon carbide and gallium nitride, which are widely used in radio frequency components and are becoming more common in 5G devices. The Chinese government views compound semiconductors as a chance to overtake other nations since they don't rely on cutting-edge chip production. Vice Premier Liu is betting that China can do this with the required backing since previous attempts at this type of centralized administration have been successful. As leading-edge process nodes get smaller and fewer businesses have adequate scale to invest in new process technologies that cost many billions of dollars, the world's semiconductor manufacturing sector has fragmented. TSMC, Samsung, and Intel are a few companies with the size to drive Moore's law to its absolute limit. However, foundries outside of these big three firms no longer have any interest in continuously investing in cutting-edge process technologies. In order to concentrate on tackling the worldwide silicon shortages, Global Foundries, the third largest pure-play foundry, Intel is still regarded as a captive foundry, has postponed investment in process nodes below 12 nanometers. The fourth largest company in Taiwan, UMC, and SMIC perceive potential in the more popular current process technologies, which deters these foundries from making the significant capital investments necessary to maintain their competitive advantage. In what would usually be ruled by the free market, several non-market factors are added during the severe geopolitical trade disputes between the US and China. However, China's pursuit of semiconductor independence has been compelled by the current trade moves and the political realities that are unavoidable in politics. As with many commercial difficulties, there is a bright spot in this gloomy picture. In order to preserve an industry dominated by foreign competitors, China is continuing its efforts to become self-sufficient in semiconductors. To achieve this, it is concentrating on creating a strong, active, and healthy silicon ecosystem. The first 7nm chip in China, according to Shanghai Tianshu Zhixin Semiconductor Company, is a cutting-edge, all-purpose cloud computing processor built on a unique GPU architecture. Tianshu Zhixin stated this week that the Big Island GPU, a data center processor, is a neural network training chip intended for AI and HPC applications as well as general-purpose computing at the cloud server level. Big Island was marketed as China's first 7nm training chip, although the fable's business did not say where it was made. Prior to this, it was thought that Chinese chip manufacturers were at least 2 generations behind cutting-edge process technology. Taiwan's Semiconductor Manufacturing Company is the primary manufacturer of 7nm products, SMIC TSMC. On the website of the Chinese business, TSMC is mentioned as a partner with other top chip design software providers including Mentor Graphics and Synopsys. Additional hints about the chip's place of manufacture exist. A 2.5 chip-on-wafer-on-substrate, initially presented by TSMC, is a multi-chip packaging method that houses 24 billion transistors, according to Tianshu Zhixin. The packing method greatly increases memory bandwidth, among other things. Comparatively, the biggest 7nm device in the world is NVIDIA's A100-ampere-based GPU, which has 54 billion transistors packed into 826mm2 of silicon. Big Island's peak performance for 16-bit floating point is 147 teraflops. It incorporates high-speed connectivity and facilitates multi-precision, mixed data training. Other numerical forms supported by the new GPU include FP32, 32-bit integer, and float16. The Chinese chip manufacturer stated that the data center GPU is also intended to solve the fundamental computer power processing problem, a claim that suggests the business hopes to fight against market leader NVIDIA, NASDAQ, NVDA, AMD, NASDAQ, AMD, and others. Big Island can process hundreds of camera video channels using artificial intelligence at a rate of hundreds of channels per second, and the performance is double that of popular goods in the market, it was further said. In 2018, work on the 7nm GPU chip began. The gadget was reportedly initially taped out in May 2020, and the chip manufacturer anticipates ramping up volume manufacturing this year. The business said that Big Island will be used for applications ranging from autonomous driving to medical research in addition to AI-based video processing. Tianshu Zhixin stated that it plans to make consistent development throughout the full product cycle and make strong and steady preparations for large-scale production and market launch of future goods, without stating a public availability date. The Shanghai city government and Taiwan's VIA Technologies formed a joint venture to create the fable's chip manufacturer, which was introduced in 2013. Thanks for watching our video. We would appreciate it if you subscribed our channel and gave us a thumb. See you.